Hello, lovely geometry students. Welcome to lesson 1.15, Rotational Symmetry. Today, our learning target is I can describe a rotation that takes a figure onto itself. So when a figure moves onto itself, just like when we said we translate to the right and then back, it looks exactly the same. Can't spin it? Never mind. We are gonna work on our competency model, and feel free to snag tracing paper from the center of the table if you need it to help visualize the rotations. Try out the do now. Which one doesn't belong? So stop and jot a thought and say why, and be ready to share out in class if we review together, but I'm gonna move on. Vocabulary review. Rotation is spinning. So you could rotate a basketball on your finger. The planets rotate in certain speeds around the sun. Symmetry. Symmetry is when you fold it in half, the angles and sides map or lie exactly on top of each other. We're going to do this student task statement live, and let's move on. Explore number 2, parallelogram symmetry. Claire says, last class I thought the parallelogram would have a reflection symmetry. What is a parallelogram? It is this figure. One pair of opposite parallel sides, and it has another pair, my gosh, of opposite parallel sides. Okay? That's why it's called a parallelogram. So last class, I thought the parallelogram would have reflection symmetry. I tried using a diagonal. So this is the diagonal from one corner to the other. As a line of symmetry, but it didn't work. So now I'm doubting that it has rotational symmetry. So Claire is talking about reflection. Just going to annotate. And Lynn is talking about rotation. So let's see what Lynn says. I thought that too at first, but now I think that a parallelogram does have rotational symmetry. Here, look at this. How could Lynn describe to Claire the symmetry she sees? So there's two types of symmetry. When you fold it, reflection, and when you spin it, rotation. So if you spun it and it maps exactly like the original image, how could Lynn describe it to Claire? Jot something down. So one possible response is that if you rotate the parallelogram, use a symbol for it. If you remember, 360 degrees around the center of the parallelogram, it would map onto itself. It basically would look exactly the same. So take tracing paper, trace the center of rotation, this dot here, and the blue parallelogram, and spin it 360 degrees, and it would look exactly like itself. Don't forget, if you don't feel like writing out parallelogram, you could use this symbol shorthand. If you have a different answer, jot it down, test it out with the tracing paper, and let's move on. Checkpoint. These are the same images as the last lesson, but that was reflection. Here we're talking and line of symmetry. Here we're talking about angle of rotation. So let's break it down. You could always draw a circle around center with compass. It needs to be an exact circle. So let me try it out. It should be inscribed, meaning all the corners should touch it, but we are going to just guesstimate, approximate. Then you can divide it into 4 sections. We know a circle has 360 degrees. So rotate around center by 90 degrees, or let's say, you know what? Not going to be perfect, but we're going to work together. All right. Divide 360 degrees by quadrants, by sections. So here we have 4 sections. And if you use a tracing paper to trace the center and the flag, if you rotate skip counting by 90, how many degrees do you have to rotate to map onto itself? Think about this knight's leg. It doesn't easily divide into 4 quadrants, but there's 3 legs. So you could divide the quadrant into 3 where the toes are. So then 360 divided by 3, the number of sections, will give you the number to skip count by. So try this out, and we are going to review once you're ready to press play. All right. So for the first one, if you rotate 180 degrees, it'll look exactly onto itself, clockwise or counterclockwise around the center. Here, this circle drawn around, it's 360 divided by 3 sections, and that's going to give us 120. So every time we spin this 120 degrees, it's going to map exactly onto itself. It's going to look the same. And ignoring the colors, you could say 360, or you could rotate 180 degrees. The black section will map on top of the white section. The dots will also map onto itself, or you could say 360 degrees. Why? Here's a circle. I'm going to divide it into 2 sections. And 360 divided by 2 is 180. I rotated 180. It's going to map exactly into itself. Put a yin yang sign if you got this right, and I'll see you next time.